You have 3 lines of symmetry. In regular polygons, it's the same number as the number of sides. So because a triangle, and these are regular, or in this case, equilateral, 1, 2, 3. Now take your straight edge that I gave you, and you're supposed to draw your lines of symmetry. And it's drawn for you right there. So go ahead and draw that in your notes. Look like this. Okay, now it's asking, did you all draw? Did you write the number 3 and draw 3 lines? It's asking about the rotation. So we are going to be rotating this. Now, oh, that's the side. Oh, I didn't know I could do that. Now I'm looking at just the triangle, okay? Here's the triangle. What is 360 divided by 3? 120. And watch. So I'm spinning this, I'm rotating. What happens on the triangle when I get to 120? See how I landed on myself? See, before I'm not on it, I keep spinning, and now all the corners are on itself. You see it? Now, what's 120 plus 120? 240. So now I'm going to go to 240. And you should be listing all of these, not just 120. It's 120, 240, right? When I made it to 240, it's on itself. And what's 120 plus 240? 360. So you should have 3 degrees of rotation. It's 120, 240, and what? 360. Any questions on the triangle? So now we're going to look at the square. And we're going to look at its line of symmetry. How many lines of symmetry does a square have? 4, because it's a 4-sided regular polygon. You have the one that goes through the midpoints and then going from diagonal to diagonal. Go ahead and draw that on your square. Did everybody get those? Okay, now we're going to do the degrees of rotation. So if I'm rotating just the square, I'm looking at the square, right? What's 360 divided by 4? 90. Watch it rotate. So I'm going around, it's not on itself, it's not on itself. But when I reach 90, if I could get it right on there. Come on. There. Oh, I had it. Right on there. Do you see how the corners all matched up? Okay, what's 90 plus 90? 180. So now I'm going to go to 180. And did I line everything up right? Yes. And then what's 180 plus 90? 270. I'm trying to get right on there. There it is. And then what's 270 plus 90? 360. So you should have all 4 of those numbers written for the degrees of rotation. 90, 180, 270, 360, right? Now I'm looking at, what's that called? What's a five-sided figure called? Pentagon. Very good. Pentagon. So now I'm looking at the pentagon. And I want to see the lines of symmetry. How many degrees, how many lines of symmetry should you have on a pentagon? 5, because it's five-sided. So it's from each vertex to the midpoint of the opposite side. That's where you get them all. So you go from the vertex to the midpoint of the opposite side. Vertex, midpoint, vertex, midpoint. That's how you get all 5. And then to get the lines, the rotation, the degrees of rotation, 360 divided by 5, we did that earlier. That's 72 degrees, right? So every 72 degrees, I should lay right on top of each other. So here's 72. 72 plus 72 is 144. Right there. See how it's on itself? What's 144 plus 72? What was that? 216? There it is. See how it's on itself at 216? And then 288. Does seeing it rotate kind of help you understand it better, I hope? I can't rotate all things. I know. That's why I have this up here. And then 360, of course. Okay, so now we're on the hexagon, right? And the lines of symmetry, how many lines of symmetry should you have for a hexagon? 6, because it's six-sided. And so this would be from vertex to vertex and then cutting it in half, both lengthwise and halfwise. That's how you get those. What about interior design? How about art? You guys were looking at art right before this. There's tons of math in art. Mm-hmm. Okay, and then heptagon, you should have 7. And this one gets a little tricky because 360 isn't divisible equally. So we kind of have to. Let's see, 360. 360 divided by 7 would be around 51.4, somewhere around there. So, did y'all get the? You should have 7. Well, you get the one going straight through the middle, lengthwise, and then you're going from vertex to midpoint of the opposite side. So vertex midpoint to the, I think all of them are vertex midpoint to the opposite side. Yep. So from the vertex to the midpoint of the opposite side. Okay. And for this one is like 51.4. So what, 50, yeah, I'm just gonna do 50, around 52. 52 is kind of close enough. And what's 52 plus 52? 104. Oh, I can't quite get it on 104. Oh, there it is. And then 104 plus 52 would be 156. Uh, this is the heptagon. Yeah. 156. No, I'm on the last one. And then 156 plus 52, 156. Oh, 208. And because of rounding, I'm getting off a little bit, so it's more like 206 because of rounding. Um, that's 206 plus 54. 260. Yeah, about there. Because of the rounding, it gets a little funky here. That was like 258. And then you got 360. Right? Oh no, there was another one like 312. Sorry. 3. Yep, about 3. Because of rounding, about 310. And then 360. Okay. Let me give you your work on this one. And the answers are on the back for both. And you have the rest of the period to work on these. Yeah, so you're rounding it. So I would do 52.4 and then just keep adding 52.4.
52.4.
Clear, clear. No. So, clear. Nice and 51.4. You have the wrong one, so put 51.4. There you go. And then you just keep adding it to it, so we'll be off a little bit because you rounded. Jordan, I already gave you credit for this because I knew you worked on it, so you already got 10 points. Because I knew who was working on it. Like we have 10 of them in here.
Oh my gosh.
Like came back with like 5 papers from me.
So you have 2 worksheets to do. At the total of 11, you have the symmetry, and then you have the interior and exterior. Yeah, for the one with the 7 sides, because you're rounding, it would be like 51.4. It won't come out exactly to 360 at the end, but it's. Yeah.
So rounding it up to 360.
Yeah, exactly, so.
51.4.